very good morning. Welcome to Chandan English YouTube channel. In this session, I am going to discuss chemistry related topic, states of matter. So in every examination, you can get one MCQs from this particular topic. So each and every student from starting to ending, listen carefully. At the end of the session, I am going to display MCQs. You must answer your answers in the comment section. Okay? All of you very good morning. Before starting the sessions, once all of you click the like button. States of matter. Okay, today I am going to discuss about states of matter. So how many states of matter are there? So what are the general states of matter? What is matter actually? Okay, so this remote is a matter. Okay, or I am a matter. Okay, this remote is completely, it is a solid. Okay, in which state it is? Okay, a particular object in which state it is, and that is considered as what, students? Matter. So matter exists in how many states? Like 5 states. It may be a solid, or it may be a liquid, or it may be a gaseous, and even 2 more states of matters are also present. So what are those? Plasma and Bose instant condensate. Okay, so these are the 5 states of matter, and I am going to explain each and everything in detail. So each and every student listen properly from starting to ending. Why? Because one MCQ will be definitely from this particular topic. Okay? Yes, very good morning, very good morning. From today, this this session is going to be start at exact 10:30. Okay, and in the evening session, I am going to take history classes at sharp 4 o'clock. Okay, so this will be continuous, students. So all of you follow these timings. Yes. How many states of matters are there? So as you all know, you will think that we have only 3 states of matters, like solids, liquids and gaseous, but not that, students. We have 5 states of matters. So what are the other 2 states of matters? Means like plasma and Bose instant condensate. So what is plasma actually? What is solid? Solid is nothing but like which is like an object. Okay, liquid is nothing but which is in the form of a fluid, and gas like gaseous state is nothing but which is in the form of air. Okay, so these are some of the examples of solid, liquid and gaseous. What is plasma actually? Okay, what is plasma? If the gaseous gets ionized, in the gaseous, if some of the electrons gets ionized, that particular state is known as what? Plasma. Example, flames. Okay, example, flame. You all know what is flame. It is a perfect example of plasma. And what is this Bose-Einstein condensate? Bose-Einstein condensate is nothing but when the particles which are present in the atmosphere, okay, when the particles which are present in the atmosphere, so they get cooled. Okay, they get cooled at absolute 0 temperature. So what happens to that particles? Even though there are many number of particles, so they all will cool down and form like a solid object, like a single object. That is known as what, students? Bose-Einstein. For example, when an astronaut enters into the space, even the water will appear as a liquid content, and that is known as what, students? Condensate, and that state is known as what? Bose-Einstein condensate. Very important. Okay, hi Chinni, very good morning. Yes, inform to your friend that class has started. So in this channel, I am going to explain each and every topic of general science like physics, biology and chemistry. So don't miss even a single session, students. Why? Because I am explaining each and every topic in detail. If you know the concept, you can easily attempt any type of MCQs, right? So for that purpose, I am going to explain the concept first, then next I am going to display the MCQs, so you will have a perfect knowledge. Next. So these are the 5 states of matters I told you. Okay, so what are those, students? Solid, as you all know, what is solid? Example, a metal rod, or this remote is a solid. And what is liquid? Liquid is nothing but which is in the form of like a fluid form. Example, water. Gaseous. So what is a perfect example of gas? Nitrogen, oxygen. So these are the perfect examples of gas. And what is this plasma? Okay, when in gaseous, when the sum of the electron gets ionized, so that particular state of matter is known as what, since plasma. Example, flame. Okay, and the next thing is Bose-Einstein condensate. So what is this Bose-Einstein condensate means, so there are number of particles, right? So these number of particles are gets cooled down. Okay, these particles are cooled down at absolute zero temperature. So what happens? So these like particles are formed like a single structure, and this condensate is known as what, students? Bose-Einstein condensate. Very, very important. For example, I have even gave you the example of this. When a person enters into the astronaut, even the like one drop of water will appear as a condensate, like a liquid state, solid state. Okay, and that state is known as what? Bose-Einstein state. Okay, very good morning, Sudha, sweetie. I think sweetie, who are you? Yes, Chinni, sweetie, Sudha, Saiteja, all of you, very, very good morning. Okay, next, just now class has started. So today's topic is states of matter. How many states of matter we have, and each and every example I have explained. Okay, and the next slide I am going to display. Interconversion of states of matter. So in this state of matter, so in every exam you will observe like questions like what is sublimation process, what is fusion, what is melting, what is boiling. So these are general questions we can observe in any examination. So these are the general terms you have to learn from this chapter. Okay, what is melting point, what is boiling point, what is freezing point. Each and every student must have knowledge regarding these terms. Okay. What is the answer for this question, students? Melting point. What is this actually? This is the temperature at which a matter converts from its solid state to liquid state. Matter means that is either it may be a solid, either it may be a liquid, or either it may be a gaseous, either it may be a plasma or condensate. Okay, so what is melting point? The point at which the matter means it is in many forms, it converts from like a solid state to liquid state. That is considered as what, students? Melting point. Perfect example is, okay, what is a perfect example? If we boil the, okay, if we boil the gold or if we boil the metal, what happens to that metal? It melts and it will converts into liquid state. So that is the perfect example for melting point. Okay, in order to create a like a small bowl, in order to create a small steel bowl or aluminium bowl, what we will do? We will melt the aluminium metal first. Okay, so what happens? The aluminium metal which is in solid state, when we heat it, what happens to it? It gets melted. So with that particular like shapes, if we pour that molten state of matter into that shapes, we will get an like a aluminium bowl. Okay, that is nothing but what, students? Melting point. Okay, what is the melting point? The point at which the matter converts from solid to liquid state is known as what? Melting point. It decreases the presence of impurity. If there are any impurities in the matter, for example, okay, in aluminium metal, if there are any impurities like sand or something, so what happens? The melting point will be decreased. Very, very important point. Okay, and the next one is boiling point. We all know what is boiling point actually. At which point the matter gets heated or it gets evaporates. Listen properly. What is boiling point actually? At which temperature the matter starts evaporating. That point is known as what? Boiling point. For example, the boiling point of water is 100 degrees centigrade. What is the meaning of that? When we heat the oil, when we boil the like water, so when it reaches at 100 degrees centigrade, what happens to that water? It starts getting evaporated. So that point is known as what, students? Boiling point. The water after heating, when it reaches 100 degrees centigrade, the water starts evaporating. That particular point at which the water gets evaporated is known as what? Boiling point. Okay, very good. Next. Okay, this is the temperature at which the vapor pressure of a liquid becomes equal to the atmosphere pressure. Okay, and what is the example? As I told you, boiling point of water is 100 degrees centigrade. What is freezing point? What is freezing point? In general, I can explain. Okay, what is freezing point? When a fluid state, example, when we put the like liquid water into the deep fridge, what happens? It gives us like solid ice cubes. That is nothing but what? Freezing point. Any fluid gets, okay, any fluid converts from liquid state to solid state at 0 degrees centigrade. Okay, when the like freezing reaches to 0 degrees centigrade, the liquid state converts into the like a cube state, solid state. That particular point is known as what? Freezing point. In general, everybody will know what are those things. Okay. Next one is evaporation. So you all know what is evaporation? Conversion of a liquid into gaseous state. For example, if we heat the water at certain temperature, that means when it reaches at 100 degrees centigrade, the water gets evaporated and the process is known as what, students? Evaporation. When a liquid water converts into vapor, that process is known as what? Evaporation. And next, what is fusion? Fusion is nothing but what, students? Melting. Oh, sorry, boiling. Fusion is nothing but what? Melting. When a solid, if we heat, what happens? It converts into liquid. That is known as what? Fusion. Evaporation. Condensation means what? If a gaseous converts into liquid, okay, if the gaseous state converts into liquid, that particular process is known as what? Condensation. Okay, sublimation, there is no liquid state in between, direct solid to gaseous. So in every examination you can expect these questions. Okay, we have discussed many times what are those processes and we are discussing again and again. Next thing, plasma. So what is plasma? As I told you, in gases, okay, in gases, if some of the electrons gets ionized, in gases, if some of the electrons gets ionized, so that particular state is known as what? Plasma. Okay, plasma is the reciprocal of what? Reverse of this Bose condensate. Plasma is the reciprocal of Bose condensate. Very, very important. So if you watch all my general science question, you can expect many questions from them. Okay, why? Because in each and every question I have explained all the concepts. So maximum questions will be covered, don't worry. So look at them once again. It is a state of matter similar to gas in which a certain portion of the gaseous particle are ionized. So what I said, in a gaseous, if the certain portion of the like atoms or electrons gets ionized, that particular state is known as what? Plasma. What are the perfect example? Like flames, lightings and auroras. So these are the perfect example for this plasma state. And next, Bose-Einstein. As I told you already, in Bose-Einstein condensate is a gaseous superfluid phase formed by atoms cooled to temperature very near to absolute zero. When the atoms or the particles, when they are cooled at a absolute zero temperature, then that all the particles will form into a single object, and that condensation is known as what? Condensate is known as what? Bose-Einstein condensate state. Okay. Next, factors deciding physical state of a substances. Okay, factors deciding physical state of a substances. So what are the factors required to define the state of a substances? So now we are going to discuss. Okay, for gaseous states, for example, for gaseous states, force of attraction will be less than thermal energy for liquid state. Okay, why? Because in gaseous states, listen properly, in gaseous states, the atoms or the particles will move freely. Okay, in gaseous state, the particles move very freely. For that purpose, thermal energy is nothing but what, students? Heat energy. For example, thermal energy is nothing but, in order to heat the gases, okay, the force of attraction between the gases will be very less. Why? Because they move very freely when compared to liquids and when compared to solids. Okay, the particles or the molecules present in the liquid, okay, the molecules or the particles present in the gases, they move very freely. For those purpose, the force of attraction between the gases will be very, very less. That means, which is nothing but force of attraction will be very lesser than thermal energy. And for liquid state, okay, this is down. For liquid state, force of attraction will be greater than thermal energy. Okay, force of attraction will be greater in thermal energy for liquid state. Force of attraction is nothing but what? In the liquid, the force of attraction between the liquids will be greater in for liquid states. And similarly for solid state, it will be more. Why? Because they are closely packed. Okay, solid is a closely packed object. The movement of electrons will be like closely, tightly packed. For this purpose, force of attraction between the molecules will be greater, and in turn, the force of attraction is greater than thermal energy. Okay, next. Intermolecular forces. So this is also very, very important, students. Intermolecular forces. What are the intermolecular forces? Nothing but the force of attraction among the molecules of the matter. So this is a matter, okay. This matter is made up of many molecules. Okay, this solid matter is made up of many molecules, right? So the force of attraction between the molecules present in the matter is known as what? Interaction force. Okay, the force of attraction present between the molecules of a single matter is known as what? Intermolecular forces. We have many intermolecular forces like dipole, London interactions, okay, ion. So these are the some of the interaction forces. So let us discuss each and everything one by one. Okay, first one is, what is this, students? The force of attraction existing among the molecules of a substances. It may be a gaseous or liquid or solid. Those forces are known as what, students? Intermolecular forces. And the next thing, greater the intermolecular forces, higher is the melting and boiling point. This is very, very important. Okay, if the intermolecular forces are higher, if the intermolecular forces are great, the melting and boiling point will be higher. I will explain why. Why? Because the intermolecular force for a solid, okay, for a solid, the molecules are tightly packed. Okay, the molecules are tightly packed, so that the force of the attraction between the two molecules will be very high. So in return, so we can say that the melting point of solid and the melting and boiling point of solids will be high when compared to liquids and gases. Did you understand what I said? Okay, when the molecules are tightly packed, the force of attraction between the molecules will be very high. As a result, the melting and boiling point of that state of matter will be high. Okay, this is very, very important thing to be noted. Attractive intermolecular forces are known as what? Van der Waals forces. And that attractive intermolecular forces are considered as what, students? Van der Waals forces. Very, very important. Okay. And the next thing, what are the different types of intermolecular forces? So now we are going to discuss the types of intermolecular forces one by one. Did you understand what I said? What is intermolecular forces actually? When actually the matter is made up of molecules. Okay, the matter is made up of molecules. If the molecules are tightly packed, okay, tightly packed, that state of matter is known as what, students? Solid. What is liquid when compared to solid? Okay, the molecules will be somewhat randomly will be there in fluid states, and in gases, the molecules present in the gases will move freely. Okay, so intermolecular forces will be higher in solids, the next in liquids, and finally in gases. Okay, and these attractive intermolecular forces is known as what, students? Van der Waals forces. These intermolecular forces are in different types. So one is what? Dipole-dipole interactions. What is this dipole-dipole interaction? Dipole-dipole interaction forces are at the molecules possessing permanent dipoles. For example, HCl is the perfect example for this. Okay, H plus Cl minus, H plus Cl minus. The attraction between the two permanent dipoles is known as what? Dipole-dipole interaction. Okay, the attraction between the same dipole, okay, like HCl, HL. This is known as what, students? Dipole-dipole interaction. Next one is dipole-induced dipole forces. Dipole-induced dipole forces is nothing but one polar molecule and one non-permanent polar molecule. Okay, when there is an interaction between a polar molecule and non-polar molecule, that is known as what, students? Dipolar induced dipolar forces. Okay, next, dispersion forces or London forces. These dispersion forces or London forces, these are the weakest intermolecular forces. They are present among non-polar atoms and molecules. Example, among the atoms are chlorine molecules. So in general, what we have to understand, so if there is attraction between two permanent dipole molecules, if there is an attraction between two permanent dipole molecules, we say it as what, students? dipole interaction. If there is an attraction between polar molecule and non-polar molecule, we say it as what, students? Dipole induced dipole forces. If there is an attraction between two non-polar dipoles, so we say it as what, students? Dispersion forces or non-London forces. They are the weakest of all the forces. Okay. Next, gaseous state. So this is very, very important. What are the characteristics of gases? So each and every students, so listen properly, students, what are the types of intermolecular attraction, and now I am going to discuss in each and every characteristics of matters. So first is the gaseous states. This gaseous state is the simplest state of matter. So what are the gaseous states characteristics? When compared to solid and liquid, okay, when compared to solid and liquid, the interaction forces of gaseous state is weakest. Why, students? Why? Because in gases, the molecules move very freely. Okay, in gases, the molecules may move very freely. For that purpose, the attraction between the two molecules will be very weaker when compared to other states of matter. So this is one. Next one is gases are highly compressible. Yes. Okay, we can easily compress gas. For example, okay, like puncturing, okay, like filling the cycle tire with the air. Okay, so we can easily compress gas. When compared to solids and liquids, we can easily compress the gas. And next thing, gases exert equally in all direction. Yes, okay, the air will exert equally in all direction. For example, fan. Okay, when we on the fan, the air will be distributed equally in all the direction. That is nothing but gases. And next, gases have much lower density. The density of the gases is very lower when compared to solids and liquids. Density will be more in solids than in liquids and finally in gases. Okay, when compared to other states of matter, the density of the gases will be very, very less. And the next thing is volume and the shape of gases are not fixed. Okay, so I am in the room. So these in this room there will be many gases like nitrogen, oxygen, carbon dioxide. Can I define the shape of the gases? No. Why? Because the gases do not have a fixed shape and value. So this is also very, very important thing to be remembered. And next, gases mix evenly and completely in all proportion without any chemical aid. Okay, without doing anything, gases will be mixed with any other thing. Okay, these are the some of the characteristics of gaseous state. Remember, each and everything is important. I think everybody know in general all these characteristics. Next, measurable properties of gases. So how can we measure the gases? Okay, we can measure the gases mass. So what is the difference between mass and weight, students? Okay, mass and weight. For example, okay, the weight, yes, okay, the mass of the the weight will be changed. Okay, in here I am x kgs. Okay, when I go to space, my weight will be decreased, but when comes to mass, my mass will be same as when I am on the earth only. So this is the difference between mass and weight. Okay, mass will never change. For example, when I am on the earth, how much mass I am? In the same way, when I reach to the space, the mass of me also same. When comes to weight, my weight is like x kgs. When I reaches to space, my weight becomes 1 by 6th, like x by 6. So that is the difference between mass and weight. How the gases will be measured? Gases will be measured in mass. It is expressed in grams or kgs. Okay, for example, cylinder. How we will measure that? Even the cylinder consists of gas only, right? Okay, the cylinder consists of LPG gas, and that gas we will measure how? We will measure in kgs, like 14 kg cylinder, 19 kg cylinder, right? Okay, that is in general we can say that gas is measured in kgs. Now volume, it is equal to the volume of the container and is expressed in terms of liters. Okay, it is expressed in mass like kgs, in volumes it is expressed in liters. And 1 liter is equal to 1000 millimeters, that is equal to 1000 centimeter cube, and that is equal to 1 decimeter cube. So these are the important things to be noted if you get any questions like problems from this concept. Okay, 1 liter is equal to 1000 ml, that is equal to 1000 centimeter cube, and that is equal to 1 decimeter cube. Very, very important notations, remember. And 1 meter cube is equal to 10 power 3 decimeter cube, that is equal to 10 power 6 centimeter cube, and that is equal to 10 power 6 milliliters, and that is equal to 10 power 3 liters. That is nothing but power, students. Okay, and the next, what is pressure? Gas pressure is measured with manometer. For example, how can we measure our atmosphere? How can we measure? By which instrument we can measure our atmosphere? With the help of barometer. So not only barometer, students, atmospheric pressure is measured with the help of barometer. How the gaseous pressure is measured? The gaseous pressure is measured with manometer. Remember, very, very important. Okay, atmospheric pressure is measured with the help of barometer, and gaseous pressure is measured with the help of manometer. What is the difference actually? Atmosphere consists of many gases. So what is this gas? Gas means there may be something specialized gases, and that gas pressure is measured by which instrument, students? By manometer. And atmospheric pressure is measured by barometer. Know the difference. Gas is different, atmospheric pressure is different. Okay, gas pressure is measured with the help of manometer, and atmospheric pressure is measured with the help of barometer. So here are some of the notations. What is 1 atmosphere? 1 atmosphere is equal to 76 centimeters of Hg. Hg means mercury. Okay, 1 atmospheric pressure consists of 76 centimeters of mercury. So these are the sum of the notations, and 1 bar is equal to 10 power 5 pascals. So what is the pressure is measured in pascals, right? Or it is measured in bars. 1 bar is equal to 10 power 5 pascals. And the next thing, pressure, measurement of pressure of a gas, open end manometer, closed end manometer. So these are the different types of manometers, like instruments, open end manometer and closed end manometer. So we don't need to discuss in such a deep thing. Okay, next one is temperature. We all know what is temperature. It is measured in Celsius scale or in Kelvin scale. Okay, what is the unit of temperature, students? We all know Kelvin. Okay, unit of temperature is Kelvin. How can we convert Celsius into Kelvins? So Kelvin is equal to T degrees plus 273. For example, okay, if we have 30 degrees centigrade, okay, for example, T is equal to 30 degrees centigrade. How can we convert this Celsius into like Kelvin? So temperature is equal to 30 plus 273 Kelvin. So what you will get, students? 303 Kelvin. So if the temperature is 30 degrees centigrade, in Kelvin we have to add plus 273. So this is the formula which is very, very important thing to be noted. Okay, and next, standard temperature and pressure means 273.15 Kelvin. This is also very, very important. Okay, standard temperature is nothing but what? 0 degrees centigrade. If T is equal to 0 degrees centigrade, how much the Kelvins will be? Plus 273. Okay, that is nothing but the standard temperature and pressure is 273.15 Kelvin or 0 degrees centigrade. And pressure and 1 bar, exactly 10 power 5 pascal. Okay, standard temperature is 0 degrees centigrade or 273.15 Kelvin, and standard pressure is 1 bar, that is nothing but 10 power 5 pascals. Okay. At STP, at standard temperature and pressure, molar volume of an ideal gas is 22.71098 kelvins. So these are the standard temperature, pressure and volume. Remember, students, very, very important. So standard temperature is 0 degrees centigrade or 273.15 Kelvin. Standard pressure is 1 bar, that is nothing but 10 power 5 bar. And standard molar volume is 22.71098 liters molecule per. Okay. Next, Boyle's law. You all know very well what is Boyle's law, what is Charles' law, what is Gay-Lussac law. Okay. So everybody know this. So what is Dalton's law? So now we are going to discuss. So these are all a part of state of matter. Okay. What is Boyle's law actually? Boyle's law is nothing but, what is it? volume is always inversely proportional to pressure. Okay, volume is always inversely proportional to pressure. So everybody know this. Boyle's law states that volume is always inversely proportional to pressure. That means, so P1 V1 is equal to P2 V2. If you want to find the formulas, P1 by P2 is equal to V2 by V1. This is the standard formula for Boyle's law. Volume is always inversely proportional to pressure when temperature is kept constant. If the temperature is constant, what we will tell that as isothermal process. If the temperature is constant, we say that process as isothermal process. Remember students, very important. Okay, what is Boyle's law? Boyle's law is nothing but volume is always inversely proportional to pressure when temperature is constant. So when temperature is constant, that particular process is known as what students? Isothermal process. So these are the graphs related when temperature is kept constant. Okay, when temperature is kept constant, these are the graphs. Okay, and next, Charles' law. So what is this Charles' law actually? Charles' law is nothing but the volume. Okay, volume is always directly proportional to temperature. Okay, volume inversely proportional to pressure when temperature is kept constant, that is Boyle's law. Volume is always directly proportional to temperature at constant pressure. So that is known as what students? Charles' law. So what comes here? Volume is always directly proportional to temperature. V1 by T1 is equal to V2 by T2. Okay, so this we have to do if any problem they give you. Okay, so what is when pressure kept constant? Okay, when pressure kept constant, and that particular process is known as what students? Isobar. So these are the diagrams when the temperature is kept constant. These are the diagrams when temperature is kept constant, and that diagrams are considered as what students? Sorry, when these are the diagrams when pressure is kept constant. Okay, isothermal process means what students? Temperature is constant. Isobar, pressure is constant. Remember, very important. Isochore. Isochore means what? If volume is kept constant. Remember students, Boyle's law, Charles' law, Gay-Lussac law, okay, like Dalton's law. We have many laws. So remember, each and everything is very important in this particular unit. Okay, next. SSC GD complete course is available on our Chandan Loix app. RRB NTPC special batch complete course is also available on our Chandan Loix app. 0 to Hero course is also available. Railway exams complete course is also available on our Chandan Loix app. SSC exams complete courses are also available on Chandan Loix app. Bank exams are also available on our Chandan Loix app. Bank SSC RRB combo courses are also available. So each and every course will be explained both in Telugu as well as English languages. Okay. Arithmetic and reasoning books, you can get these two books at $9.99 only plus delivery charges applicable. APPSC, TGPSC, essay constable courses are also available on Chandan Loix app. Now next comes Gay-Lussac law. So what is this Gay-Lussac law? So as I told, okay, Gay-Lussac law is nothing but when volume is kept constant, okay, when volume is kept constant, pressure is directly proportional to temperature, and that if the volume is kept constant, that particular process is known as what students? Isochores. So in general, instead of reading everything, okay, I will give you a table, just note it down or remember it. Okay, Boyle's law is nothing but what students? Volume is inversely proportional to pressure when temperature is constant. And next comes Charles' law. Charles' law means volume is directly proportional to temperature when pressure is kept constant. And next is Gay-Lussac law. It is nothing but pressure is directly proportional to temperature when volume is kept constant. So if temperature is constant, we say it as what? Isothermal process. When pressure is kept constant, we say it as what? Isobar. And when volume is kept constant, we say it as what? Isochores. So remember students, very important. So in 3 lines you can get lot of concept. That is in simple, and you can expect one question exactly from these things. Okay? Yes. Next, Avogadro's law. So this is very important thing to be noted. What is this Avogadro's law actually? Okay, it states that equal volumes of all gases under the same conditions of temperature and pressure contain equal number of molecules. Okay, so what is this actually? Equal, okay, equal volumes of all gases. For example, so this is some gas, this is some gas, this is some gas. Okay, so equal volumes, they are having same volumes like V1, V1, V1. Equal volumes of all the gases at the same temperature and pressure consist of equal number of molecules. So this will have the same molecule, this will have the same molecule, this will have the same molecule. And that particular law is known as what, students? Avogadro's law. Okay, what is this Avogadro's law? Equal volume of all the gases, equal volume of all the gases at constant temperature and pressure will have equal number of molecules, and that particular process is known as what, students? Avogadro's law. Mathematically, V by N is equal to K. Nothing but volume by number of molecules will be constant. Okay, V is equal to N. Okay, how can we write this? V by N is equal to K. Next, molar gas volume. The volume of 1 mole of a gas, that is 224 liters at STP, is known as what? Molar gas volume. Nothing but, what is this molar gas volume? As I have discussed already, standard temperature pressure molar gas volume will be 224 point something, and that particular volume is known as what, students? Molar gas volume. Okay, next, ideal gas equation. This is very, very important. So these are the equations which I have already discussed. From these equations, what you will get, students? PV is equal to nRT. Why? Because, for example, okay, V is inversely proportional to 1 by V. V is directly proportional to T, and P is directly proportional to T. By this, what you will get, students? V is directly proportional to NT by P. We will get this. By doing all this, we will get PV is equal to nRT. Okay, this is the ideal gas equation. Okay, this is the ideal gas equation. In general, in universe, any gas cannot be ideal gas. Okay, if a gas satisfies this equation, remember each and every students, very, very important. If a particular gas satisfies this equation, then that gas is considered as real gas, ideal gas. If any gas, it may be any gas, if that gas, okay, satisfies the ideal gas equation, then that gas is considered as what, students? Ideal gas. If that gas does not satisfy this particular ideal gas equation, then we will say that gas as real gas. Okay, in general, in universe, most of the gases does not satisfy this equation. For this purpose, we call the most of the gases as what, students? Real gases, but not ideal gases. If the gas satisfies this equation, it is a ideal gas. So most of the gases does not satisfy. So those gases are considered as what, students? Real gases. Okay. This is also known as real ideal gas equation. R is known as universal gas constant. So in our like 10th class, we have remembered, okay, what is the universal gas constant is denoted as? Universal gas constant is denoted by R. So what is the, what you can see this? See, if a gas satisfies this equation, that gas is considered as ideal gas. But in general, in universe, we cannot find the ideal gas. Okay, approximately it will match, but we cannot find the ideal gas. If that equation does not satisfy, if a gas does not satisfy this equation, we consider them as what? Real gas. Okay, that's it. And what is the general value of universal gas constant? 8.314 joule per kilo per mole. So this is the general numerical value of universal gas constant we have studied in our. What is directly or indirectly proportional? I didn't get you, Lakshmi. Okay, ideal gas. So as I told, the gas which obeys the equation PV is equal to nRT at every temperature and pressure range strictly is known as ideal gas. Okay, at a given temperature and pressure, if a gas satisfies the particular equation, ideal gas equation, we say it as what, students? Ideal gas. If it does not satisfy real gases, since none of the gases present in the universe strictly obeyed the equation PV is equal to nRT, hence they are known as real or non-ideal gases. Real gases behave really at a low temperature and high temperature. Okay, so listen properly, I am explaining you once again. So I have explained what is Boyle's law, what is Charles' law, what is Avogadro's law, what is Gay-Lussac's law. So by solving all the equations we got, finally we will get an equation PV is equal to nRT. And that equation is considered as what, students? Ideal gas equation. If a gas at standard temperature and pressure, if it satisfies the given ideal gas equation, that is considered as ideal gas. So most of the gases in our universe actually do not obey this ideal gas equation. So those gases are considered as what, students? Real gases. So real gases sometimes, okay, they can become ideal gases at a very low pressure and high temperature. Okay, real gases at sometimes they can behave as ideal gases at a very low temperature and very low pressure and high temperature. Remember, very, very important. Yes, you can, Lakshmi. Okay, you can say. Pressure is inversely proportional to volume or volume is inversely proportional to pressure. You can say. Why I am mentioning like V only here means finally we will get an equation, right? Why? Because in both of this equation, V is only at the starting place. For this purpose, I have put all the V's in the first place. Okay, Lakshmi? Done. Next, Graham's law of diffusion. What is this Graham's law of diffusion? I have already explained you what is diffusion. Diffusion is nothing but the process of higher concentrated particles entering into the lower concentrating particles is known as what, students? Diffusion process. Okay. Now, what is this Graham's law of diffusion? Under similar conditions of temperature and pressure, the rate of diffusion of gases are inversely proportional to the square root of their densities. So, what you have understood there? Okay, the rate of diffusion of gases, nothing but higher concentration is nothing but what, students? High density particles. Lower concentration is nothing but what, students? That particles consist of very less density. Okay. Now, what this Graham's law of diffusion is saying? The rate of diffusion always inversely proportional to the square root of their densities. Very, very important. That means R1 by R2 is equal to under root D2 by D1. That is nothing but R is always, rate of diffusion is always inversely proportional to the square of their densities. Okay, by this you can write by R1 by R2 is equal to D2 by D1. So this is very, very important. Okay, next. Dalton's law of pressure, we have discussed many times. What is this Dalton's law? The sum of all the partial pressures of a fluid is always, it is equal to the total pressure. Total pressure is the sum of all the partial pressures. Okay, total pressure is the sum of all the partial pressure. That is nothing but what is Dalton's law. In detail we will discuss, don't worry. Okay, what is Dalton's law? At constant temperature, the total pressure exerted by a mixture of non-reacting gases is the sum of partial pressures of different gases present in the mixture. So what you have understood there? At a constant temperature, okay, it's constant temperature. So there are some of the non-reacting gases. Okay, there are some of the non-reacting gases, and that non-reacting gases pressure. Okay, the total pressure will be sum of the partial pressure of each individual gases. Okay, so that law is known as what, students? Dalton's law. In general, okay, at constant temperature, the total pressure is equal to the sum of the partial pressures of all the non-reacting gases. So that is considered as what, students? Dalton's law. Okay. P is equal to P1 plus P2 plus P3. So in general I will explain. So this is one gas, students, this is one gas, students, this is one gas. So this is having one P1 pressure, this gas is having P2 pressure, and this gas is having P3 pressure. So these three are combined. Okay, these three are combined. They are non-reacting gases. That means each gas will not be mixed with each gas will not be mixed with any other two gases. Okay, in that particular cases, what is the total pressure of this mixture? What is the total pressure of this mixture? And that is nothing but total pressure is equal to like a partial, sum of the partial pressures of P1 plus P2 plus P3, and this law is known as what, students? Dalton's law. Okay, next. Deviation from ideal behavior. At high pressure and low temperature, the gases deviate considerably from the ideal behavior. So what it is actually? Okay, deviates means what, students? Deviation. Okay, now this solid have some particular behavior. Okay, this solid have some particular behavior. If I heat, if this solid is at like a high pressure and low temperature, that means I am beating it, I am giving pressure and I am heating it. Okay, generally I am explaining, students. So what is this actually? Deviation from ideal behavior. That means it is ideal now. It is ideal now and it will behave ideally. Why? Because anything is not acting upon it. I am applying a lot of pressure and I am heating it. Can it remain the same? No. Its ideal behavior will be deviated. So that is nothing but what it is on the blackboard. Okay. At high pressure and low temperature, the gases deviate considerably from the ideal behavior. And that deviation, it can be expressed in terms of compressibility factor. So Z is equal to PV by nRT. Okay. And how much it is deviated, that can be expressed in terms of compressibility factor. What is the definition for that compressibility factor? Z is equal to PV by nRT. As we all know, what is this PV is equal to nRT, ideal gas equation. Okay, once I am going to explain, students. So this is a solid object, right? So it is ideal and it behaves ideally. Why? Because nothing is acting upon it. If a high pressure and low temperature is acting upon it, so what happened to it? So there appears some deviation for this solid object. If we heat it and if we apply pressure on it, there will be somewhat deviation for this solid object. And that deviation is considered as compressibility factor, and we can measure that compressibility factor in terms of Z is equal to PV by nRT. Okay. And the next thing, in case of ideal gas, for ideal gas Z will be 1. Why? Because for ideal gas it will not undergo any changes. For real gas, as it does not satisfy this ideal gas equation, Z will not be 1. Okay, remember, students, very important. I am discussing in detail with perfect examples. So if you listen properly, you can easily understand this session in detail. Okay, if your examination is somewhat moderate to difficult level, so these types of questions will be asked. Next, negative deviation. In such cases, if Z is less than 1, the gas is more compressible. Now, okay, so listen properly, you have understood what is compressibility factor. If there is any deviation at high temperature and high pressure and low temperature, that deviation is considered as compressible factor, and that is PV by nRT. For ideal gas, Z will be 1. For real gas, Z is not equal to 1. If Z is less than 1, we can say that gas is more compressible. That means we can compress the gas at a very fast rate. If Z is greater than 1, the gas is less compressible. So that is what we have identified there. Okay. And the next, the factors affecting the deviation are, so nature of the gas, pressure, temperature. So we have already discussed. If we do something, if we act something to this, okay, there will be deviation. So those are the factors which are reason for the deviation. Next. So these are the van der Waals equation. I have told you what is actually van der Waals forces. Van der Waals forces are not, students, attractive forces of intermolecular. Okay, attractive forces of molecules are considered as what, students? Van der Waals forces. Okay, so after volume and pressure correction, Van der Waals obtains the following equation for n numbers. So these are the Van der Waals equation. This is not that important. Okay, next. So these are the some of the important definitions, students, like critical temperature, critical pressure, critical volume and Boyle's temperature. These are very, very important. Okay, each and every students listen properly. So these things are very, very important in your exam point of view. Liquefaction of gases and critical points. Okay, what is critical temperature actually? It may be defined as the temperature above which no gas can be liquefied. Okay, gases can be liquefied, right? If a gas condensation. Okay, if a gas cannot liquefied at a certain temperature, that means if it reaches at a certain temperature, there it cannot be liquefied. That particular temperature is known as what, students? Critical temperature. And the critical temperature of carbon dioxide is 31.1 degrees centigrade. That means carbon dioxide, when it reaches at 31.1 degrees centigrade, it cannot be liquefied. Okay, when it reaches to 31.1 degrees centigrade, it cannot be liquefied, and that particular temperature is known as what, students? Critical temperature. And next thing, so these are the some of the important critical values of important gases. Make a screenshot of it, students. Okay, next, and this is the formula to find the critical temperature. Okay, critical temperature is equal to 8A by 27 RB. And the next come critical pressure. What is this critical pressure? At critical temperature, the pressure needed to liquefy a gas. What is critical pressure? At critical temperature. So you know what is critical temperature? At critical temperature, the pressure needed to liquefy a gas is known as what, students? Critical pressure. Okay. Next, critical volume. The volume occupied by 1 mole of gas at critical temperature and critical pressure. Nothing but the volume at critical temperature and critical pressure is known as what, students? Critical volume. Next, Boyle's temperature. Temperature at which a real gas exhibits ideal behavior. What is this Boyle's temperature? The temperature at which the real gas exhibits the ideal gas behavior, that is known as what, students? Boyle's temperature. Okay. These are some surface tension. What is surface tension? I have discussed many times. Surface tension is nothing but, so a rain droplet, okay, a rain droplet when it falls on the earth, so what happens? The rain droplet will be shrinks, okay. So this is the rain. So when it falls on the ground, how the rain droplet will appear? It will appear in this manner. So that is nothing but it will shrinks. And that particular shrinking factor is known as what, students? Surface tension. This surface tension always denoted by gamma, and it is measured in newtons per meter. Okay. Surface tension, did you understand what I said? When a rain droplet falls on the earth, the rain droplet will be shrink. Due to which property, students? Due to which property? Due to the property of surface tension. That surface tension is denoted by gamma, and what are the units? Newtons per second. Next, viscosity. Viscosity is nothing but stiffness. Okay, for a certain fluid, if there is a stiffness is nothing but gummy nature, and that particular property is known as what? Viscosity. Okay, next, that's it. Here comes the MCQs. Till now what I have explained, now we are going to answer to those MCQs. So students, actively participate in these MCQ questions. Yes. Till now what I have explained? Yes. Okay. How many states of matters are known at present? 3, 4, 5, 6. So once again I am going to explain each and everything, students. So don't worry. I think most of the students did not listen properly. Why? Because all will feel theory is not interesting. But I will explain again and again. Don't worry. Okay. How many types of matters are there as of now? So what are those, students? Solid, liquid, gaseous, plasma and Bose condensate, and have each even explained what is what. Okay. What is the answer, students? Very good. 5. Which one of the following states of matters are commonly found under normal conditions? plasma and Bose instant condensate, solid, liquid and gas, gas, plasma and liquid, solid, plasma and gas. In normal conditions, what are the states of matters? Tell me. Tell me, students. Yes, okay. Solid, liquid and gaseous in normal conditions. If something is like in gaseous, if some of the gases gets ionized, so that is plasma. If all the particles got cooled down at absolute zero temperature, and that is Bose constant. In normal, how many types of states of matter at normal condition? Solid, liquid, gaseous. Very good. Next. The temperature at which a solid changes into liquid is called freezing point, boiling point, melting point, triple point. Tell me. Solid changes into liquid. Okay, listen properly. Okay. The temperature at which the solid changes into liquid state, that particular point is known as what? Melting point or boiling point or triple point or freezing point. Tell me, students, each and every students mention your answers in the comment section. Very good, very good. Melting point. Okay. And what is the boiling point of water? 100 degrees centigrade. Okay. Very good, students. The melting point of a substance decreases in the presence of pressure, heat, impurity, vacuum. So, this is very good question. I have already explained you. So, melting point means what, students? I have even explained you by taking an example, aluminium metal. Okay, aluminium metal, at first it is in like solid state. When we melt, we will get the liquid state. Okay, if we pour in the shape, we will get an ball. Okay, so how, yes, if there is an impurity, the melting point of a particular thing will be decreased. Very good. The boiling point of water at atmospheric pressure is 0 degrees centigrade, 50 degrees centigrade, 100 degrees centigrade, 273 degrees centigrade. Yes, students, each and every student mention your answers in the comment section. No one should sit idle. Yes, what is the boiling point of water? That means at what temperature, if it reaches at what temperature, it starts getting evaporated. Yes, at 100 degrees centigrade. Evaporation differs from boiling because evaporation occurs only at boiling point, occurs at temperature, requires pressure increase, occurs only in solids. Evaporation differs from boiling because evaporation. Tell me, students. Yes. So, tell me, what is the answer? Who is going to give answer for this question? If you understand what I said perfectly, you can answer to this question. What is the difference between evaporation and boiling point? Tell me. I have even explained you. Very good, very good. Rama, okay. Rama. Okay. The evaporation occurs only at the boiling point. Boiling point is different. Even the water gets boiled. But when it reaches at the boiling point only, it starts evaporating. Okay, very good, students. The phenomena responsible for cooling of water in an earthen pot is condensation, sublimation, evaporation, freezing. In general, so they are heating, they are boiling the water in pot. So what that process is known as? You can easily answer to this question, students. Okay, Sharma, okay. Okay. And what is the answer, students? Everybody mention your answers in the comment section. So, the process of boiling the water at earthen point, that process is considered as what? Evaporation. Very good. Condensation means gaseous to liquid. Sublimation means solid to gaseous directly. And freezing means liquid to solid. Okay? The temperature and pressure at which all three states of substances coexist is called critical point, triple point, melting point, boiling point. Very easy question, students. I think very important question. Okay, the temperature and pressure at which all the three states of a substance is coexist. So there happens, yes, okay, there will be a point, students, at that particular point the states of all will be coexist, like solid, liquid and even gaseous. Okay, for example, I will tell you a perfect example. So there is a thumbs up bottle. Okay, that thumbs up bottle I have kept in a deep fridge. It is half cooled. So there exists liquid state, there exists some like a ice cube, and there exists even gas, and that is considered as what, students? Triple point. Okay, yes. The triple point of water occurs at 0 degrees centigrade and 1 atom, 0.0098 degrees centigrade and 4.58 mmHg, 100 degrees centigrade and 760 mmHg, 273 K and 1 bar. So this is easy question. I think everybody will answer. The triple point, so as I told, okay, what is triple point means? Just now I have explained you with an wonderful example like a thumbs up bottle. When we keep the thumbs up bottle in deep fridge and after some time it gets half cooled, okay, and some will be in the solid state and some thumbs up will be in the liquid state, and the gas will be already present in the thumbs up bottle itself. That means that particular thumbs up bottle, it reached at the triple point. And what is the answer for this question, students? And the answer for this question is option 2. Okay, yes. Plasma is a state of matter in which particles are neutral atoms, fully neutral molecules, ionized gaseous particle, closely packed molecules. Tell me, plasma is also one of the states of matters, right? So how it is made up of? Tell me, students, what is the answer for this question? And each and every students who needs classes in English medium, even your friends or relatives, do share this video to them, students. Why? Because in upcoming days, we are going to discuss a lot of information in this session also. So what is the answer? Very good. Bose-Einstein condensate is formed when atoms are cooled to room temperature, high temperature, near absolute zero, above boiling point. Yes, very good, very good. Okay, Bose-Einstein condensate, it is also one of the states of matter, right? So how it is made up of? It is made up of near absolute temperature. So when we cool all the particles at absolute near zero temperature, then all the particles will become a single object, and that is known as what? Bose-Einstein condensate. Which force is weakest among intermolecular forces? Dipole-dipole interaction, ion-ion interaction, London dispersion force, hydrogen bonding. So as I told you already, HCl, okay, if there is an interaction between two permanent dipole molecules, that is considered as dipole-dipole. If there is an interaction between polar molecules and non-polar molecules, dipole-induced dipole forces. If there is an interaction between two non-polar molecules, and those are considered as what? Very good. Okay, London dispersion force. Very good, students. Dispersion forces increase with decrease in electrons, decrease in size, increase in molecular size, decrease in temperature. Dispersion forces increases with, tell me. Yes, very good. So dispersion forces are considered as what, students? Very weak forces. Tell me, they will increase if increase in molecular sizes. Okay, very good. Which of the following is not a characteristics of gases? Highly compressibility, fixed shape, raw density, random motion. Tell me. Tell me, students, this is very like a thinkable question. So gases, does the gas have a fixed shape, or does it have the high compressibility? Does it move randomly, and does it have low density? So which is not? Yes, it does not have a fixed shape. Why? Because gases will move randomly in a free moving way. Okay, it does not have any fixed shape or volume. Very good, students. Which instrument is used to measure atmospheric pressure? Atmospheric pressure is measured by using which instrument? Yes, everybody who are in the live session, do mention your answers in the comment section. And what is the answer for this question? And in the evening session, I am going to discuss like Chalukyas, Pallavas and Rashtrakuta dynasties. Okay, in detail. Yes. Yes, barometer. And manometer is for gaseous pressure. Okay. At a standard temperature and pressure, the molar volume of an ideal gas is approximately 11.2 liters, 22.4 liters, 22.7 liters, 24 liters. I have even explained you. What is the answer for this question, students? At a standard temperature and pressure, the molar volume of a gas is approximately, yes, okay, it is approximately, I have even told you the volume. Standard temperature is 0 degrees centigrade or 273.15 Kelvin, and pressure, standard pressure is 1 bar, that is 10 power 5 pascals, and standard molar volume is 22.4 liters. Very good. Boyle's law relates pressure with temperature, volume, density, mass. So what is Boyle's law? Boyle's law is nothing but what, students? Okay, volume is always inversely proportional to what? That means it relates with, Boyle's law relates pressure with what? Hurry up, guys. Mention your answers in the comment section. Yes. Boyle's law relates pressure with what? Each and every students who are in the live session, once all of you click the like button, and please do share this video to your friends and relatives who needs classes in English medium. Yes. Charles' law states that volume is directly proportional to pressure, density, absolute temperature, molecular mass. What is Charles' law? Charles' law is nothing but, yes, very good, Madhuri. What is Charles' law? Okay, and the answer is Charles' law is always volume is directly proportional to temperature when pressure is constant. And what is the answer? At absolute temperature. Very good, Chinni. According to Avogadro's law, equal volumes of gases at the same temperature and pressure contain equal mass, density, number of molecules, pressure. Okay, what is Avogadro's law? Even I have explained you. So equal number of volumes, equal volumes of gases consist of equal number of what? Yes, equal number of molecules. Deviation from ideal gas behavior is maximum at low pressure and high temperature, high pressure and low temperature, low pressure and low temperature, high temperature. I have even explained you what is deviation. For a particular gas, so there exists some deviation. Okay, in which cases? At low pressure and high temperature, or low pressure and low temperature, in which cases? And that particular deviation is considered as what, students? Compressible factor. If compressible factor Z is equal to PV by nRT. For ideal gas, okay, for yes, low pressure, high temperature. Very good. RRB NTPC special batch complete course is also available on our Chandan exam. SSC GD complete course is also available. 0 to Hero complete course is also available on our Chandan exam. SSC exam complete courses are also available. Railway exams complete courses are also available. Bank exams, SBI PO Clerk, IPS PO complete courses are also available on Chandan exam. Bank SSC RRB combo courses are also available. Arithmetic and reasoning. So these dupes you can get it only for 999 plus delivery charges applicable. APPSC, TGPSC, SI constable courses are also available. APPSC, TGPSC Group 2 courses are also available, single subject courses are available. So all the courses you can get these courses in English as well as Telugu languages. So please subscribe to Chandan Likes Telugu, English and main channel so that every time you have a live session you will get a notification. Okay, so daily I am going to continue this general science series in Chandan Loik's English YouTube channel at sharp 10:30. So daily with one topic of each subject like physics, chemistry and biology. And in the evening session in Chandan Loik's Telugu YouTube channel, I am continuing Indian history. Okay, and today I am going with Chalukyas, Pallavas and Rashtrakuta dynasties. Okay students, bye.